नमस्कार दोस्तों, मैं श्रीधर आज आपके लिए एक नया टॉपिक लेके आए हैं। आज का टॉपिक है सिंबल ऑफ डायरेक्शन कंट्रोल सर्किट्स। डायरेक्शन कंट्रोल सर्किट्स। In this section, we'll learn how simple circuits work. Before learning this session, please answer the following questions. What is the correct symbol? A. Yes. What is the correct way of showing the tank connections? Sketch A, sketch 2, both sketch A and B, none, don't know. C, both sketch A and sketch B. If a direction control valve is required to move left, right, and center position, then how many positions should be there? Three positions. In this section, let us see how simple hydraulic circuits works. After understanding the simple circuits, you can understand the complicated circuits also. In the hydraulic system, hydraulic circuit is drawn by using pumps, valves, filters, strainers, direction control valve, etc. Straight line indicates pipe through which pressurized oil and return oil flows. This is the symbol of flexible hose. Let us draw a simple hydraulic circuit in which a 3 by 2 direction control valve used and a single acting cylinder is used. While drawing the circuits, first the hydraulic components are drawn at appropriate locations. Usually cylinders are drawn at the upper part of the circuits. This is the symbol of spring return single acting cylinder. Valves are drawn below the cylinders. This is the symbol of 3 by 2 spring return manually operated direction control valve. There are three ports P, T, A, and there are two positions, that is position 1 and position 2. In the right side coil, A is connected to T. This is the normal position. Pump port P is blocked. In the left side square, port P is connected to A. Tank port T is blocked. When handle is operated, valve comes to the position. This position is drawn next to the handle. These valves can be drawn at any location below the cylinders. If, if the valve is drawn at this position while connecting the cylinder, a slant line is drawn. Usually straight line and horizontal vertical lines are drawn If the valve is drawn at suitable position, it can be joined by a single straight line. Always remember that tank connection means the normal position of the valve. Pump is drawn directly below the P port of the direction control valve, so they can be joined by a single straight line. Below the pump, strainer and tanks are drawn. T port of the valve is connected to the tank. There are two methods for showing the tank connection. One method is to draw a small tank symbol near just below the tank port and join by a straight line. Another position is to draw only one big line to the tank. Always, relief valve is placed just next to the pump to protect the hydraulic components from excess pressure. You will learn about relief valve in the next chapters in pressure control circuits. So in this chapter we shall draw the relief valve by a simple square. When two lines joined by a small dotted point, relief valve outlet is connected to the tank. This is how hydraulic circuits can be drawn. Now let us see how oil flows in the circuit. When pump rotates, oil enters into the pump through strainer and suction line. Pump delivers oil to the P port and relief valve port. If the handle of the direction control valve is operated, pump port is connected to port A. Oil gets into the cylinder and pushes the piston. Piston makes forward movement. Spring get compressed. When piston reaches the extreme position, oil pressure in the system increases. When the oil pressure is more than the relief valve pressure setting, relief valve opens and oil flows to the tank. If the handle is released, direction control valve moves the valve position, spool position to the normal position. In this position, valve cylinder port is connected to tank port through port A and T. Pump port P is blocked. As cylinder is connected to tank, ports P and T are connected. Spring pushes the oil out of the cylinder and through A port to T port, oil returns to the tank. As the pump has been running continuously, the pressure port P is closed. The oil flows through the relief valve to the tank. Due to high pressure, the relief valve opens and oil flows to the tank continuously. Now let us see again the direction control valve used to change the. Before seeing the circuit again, please draw the circuits on a paper. It has to be remembered forever in future. When pump rotates, Oil enters into the pump through strainer. Pump delivers oil at the inlet of the relief valve and pivot of the direction control valve. If the handle of the direction control valve is operated, pump port is connected to port A of cylinder direction control valve. Oil gets into the cylinder and pushes the piston rod in forward direction, and piston takes forward movement. Spring get compressed. When pitches the extreme position, oil pressure increases, and oil pressure when more than the relief valve setting pressure, relief valve opens and oil flows to the tank through the relief valve. If the handle is spring is in a direction control valve, moves the valve into normal position. In this position of the valve, cylinder port A is connected to tank through port A and T. Pump port P is blocked. A cylinder is connected to tank through port A and T. Compressed spring pushes oil out of the cylinder and this oil flows to the tank through port A and port T. As the pump has been running continuously, the pump in the direction control valve, the pump port is closed. When the oil pressure reaches the more than the relief valve setting, oil flows into the tank through the relief valve. In this circuit, piston remains stationary at a extreme position of stroke. If we want to hold the piston at intermediate position, we will see in the next page. In one position of the DC ball, piston moves in the forward direction and reaches the extreme right position. In another position DC valve, piston makes retract movement till the end of the head end to the extreme left position and oil returns to the tank. So if you have to stop the piston at any intermediate position, another position is required. This valve has three ports and three positions. This is 3 by 3 DC valve. This is the neutral position. In this position of the valve, the piston has to remain stationary at any intermediate position of the cylinder. There should not be any oil movement. That means A port should be blocked, P and T port also blocked. They can be interconnected as per requirement of the hydraulic system. If three position is required, there should be three position of the DC valve. The direction control valve chapter is completed now. दोस्तों, if in doubt, please comment me, subscribe me, or share to your friends, or like if the video likes you. दोस्तों, अगर ये वीडियो आपको अच्छा लगा है, इसको शेयर कीजिए, सब्सक्राइब कीजिए और बेल आइकन को दबाइए। थैंक यू।